Series. Here in this session we are going to discuss what are the summary of the chapter, that is legendary function, and here we are going to discuss only the main point, main formula of this chapter, which can be asked in the exam like CSRNet, IIT exam, GATE, JEST, etc. Okay, so let's start it. Legendary equation. The main form of the legendary equation is given that 1 minus x squared double derivative of y minus 2x derivative of y plus n into n plus 1 y is equal to 0. We can write this equation in this form, that is the derivative of 1 minus x squared dy by dx plus n into n plus 1 into y is equal to 0. Just like that, if we derivative this function, that is first we take this 1 minus x squared as u and dy by dx as a v, then we derivate the v function first, taking outside 1 minus x squared, then this will be in this form, and again we can differentiate 1 minus x squared taking dy by dx as outside, so we can get minus 2x and dy by dx in the outside, and this function, this term will be same as well it is in this equation. Okay, so this how we can write this legendary equation in two form. Okay, so let's discuss about what are the legendary polynomials. Okay, there are two types of legendary polynomials. First one is this, that is 1 pn of x is equal to 1 3 5 dot 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 2n minus 1 divided by n factorial into x square minus n into n minus 1 by 2n minus 1 into 2 x to the power n minus 2 plus dot dot dot. This is not so much important equation because this is derived from this main equation, and this equation never asks in your exam, even in your semester exam also. Only you have to derive the legendary equation, that is which we have already studied in previous minutes. Legendary function of the second kind belongs to that type not asked in any exam, cannot be asked in any exam because it can be derived from the legendary equation. Okay, so now what are the general solution of the legendary equation? The general solution of the legendary equation are y is equal to a pn of x plus b qn of x. Here a and b are two arbitrary constants. We can change this constant as well as it in the form in the solution. So let us discuss about the Rodriguez formula. By the help of the Rodriguez formula, we can define the legendary function. We can define the legendary equation, that is Pn of x is equal to 1 divided by 2 to the power n factorial nth derivative of x square minus 1 to the power n. This is very simple formula. I hope you will easily remember this formula. So next equation is our legendary polynomials in different forms. If we take the value of n from 0 to infinity, then we get different types of value of the pn of x. Just like that, if we take n is equal to 0, then we get p0 of x is equal to 1 divided by 2 to the power 0 into 0 factorial, that is 1. 0 factorial means 1 and above one side, so it is 1. If we take n equal to 1, then p1 of x will be x. How? The derivative of 2x is 2x and 1 by half is in the above side, in the front side, so 2 are cancel out, then we get only x. If we take n is equal to 2, then we get p2 of x is equal to 1 by 2 3x square minus 2, and if we take n equal to 3, then we get this value, and we have to remember the 4 value only, because the function always given x cube, not exceed the x cube. If it is exceed x cube function, then it is more complicated, and x cube means this is p3 of x. X cube means p3 of x, so we have to remember only the legendary function up to p3 of x, only p3 of x. This value cannot be important. If it is asking for finding the value of p4 and p5 and something, then we can easily calculate from this p3 by putting n equal to 4 and 5 and everything. Okay, so remember this for value of legendary equation, then you can easily solve the problem. Okay, now let us going to what are the generating function of legendary polynomial. Okay, generating function means that is the equation define the generating function, that is 1 minus 2 xz plus z squared to the power minus 1 by 2 is equal to summation of Pn of x into z to the power n. Here this term is not written, but it is given, it is given in this line, that is prove that Pn of x is a coefficient of z to the power n in the expansion of 1 minus 2 xz plus z squared to the power minus half in ascending power of x. So this means this summation of Pn of x into z to the power n. Okay, so you have know this formula. So now discuss a very important formula, that is a recurrence formula. There are 6 recurrence formula. By the help of this formula, we can prove many problems. We can find the value of many, that is many complicated differential equation. So we must have to know this 6 equation and keep this equation in our tip of our tongue. So let's start it. First equation is n plus 1 pn of x p1 of x whole of x is equal to 2n plus 1 x pn minus n pn minus 1. Similarly, first you have to remember this thing and then remember these 3 equation, that is number 2. Then you proceed to number 2 equation and then it is in this sequence. Okay, so change is, that is 3 equation must be in the 2, because here n plus 1 and 2n plus 1 for more easier remembering, this sequence can be followed. So 2n plus 1 pn of x is equal to pn plus 1 prime minus pn minus 1 prime of x. That is very simple formula, that is prime means that is derivative of this function. And now proceed to number 2 formula, that is npn of x is equal to xpn prime minus pn minus 1 prime. The simple way to remember this formula, that is in the 2 number equation you have remember this formula. So last term in this position, same position, but you have to change the first term, that is this, and change this form. Okay, so you can, in this way you can easily remember this thing. Now continue our equation, that is number 4 pn prime of x is equal to xpn minus 1 prime plus npn minus 1 pn minus 1 prime of x. This is very easy. Take common pn minus 1 prime of x, then this will be formed in the x minus n. This is very simple formula, you can convert it in this way. Okay, so the x plus n. Next is 5, that is x square minus 1 pn prime of x is equal to n into pn minus 1. Okay, if you again derive this formula, then if you put n is equal to n plus 1, then this type of formula can be taken. In pn of x is more additional term in this here in this chapter. Okay, so now going to the MSc level course, that is the Laplace first definite integral for pn of x, that is the Laplace given some equation for the legendary function, that is pn of x is equal to 1 by pi integration from 0 to pi x plus or minus square root of x square minus 1 cos phi whole power n d phi. This is most important formula, because by the help of this we can prove many equations. Okay, next is Laplace second definite integral for pn of x, that is very simple, 1 by pi integration from 0 to pi d phi in this position, but change is that this function. Okay, x plus or minus square root of x square minus 1 cos phi to the power n plus 1. Here n plus 1, but in the first equation this is in the upper side in the numerator, and this the power will be only n, but here the situation is different, it's opposite, that is this function is in the denominator side and the power will be n plus 1. Okay, this, so I hope you can easily remember these two Laplace equation for definite integral. Okay, next one is the Fourier-Legendre expansion. Okay, so Fourier-Legendre expansion is nothing but the finding the value of the constant of the integration. So we have to find the solution of the differential equation or equation. So we have familiar with the constant, that is C1 C2 C3. For finding that constant, we have used this formula, that is Cn is equal to 2n plus 1 by 2 integration from minus 1 to plus 1 f of x pn of x dot dx. You can easily remember this thing by n, by converting this formula, that is n plus half, and that is integration from minus 1 to plus 1 f of x pn of x dot dx. This is, we have in this, by the help of this formula we can find out the value of the constant, that is c1 for n is equal to 1, c1 for n equal to 2, c2, by putting the f of x and value of the pn of x. I Before going to the next page, i I am going to say something, that is the recurrence formula is most important, because here we can put the recurrence formula by which type, p1 of x, p2 of x, p3 of x. Recurrence formula most needed, so you have to remember that recurrence formula. Now Sturm-Liouville equation, that is derivative of px dy by dx plus lambda q plus r of x whole of y is equal to 0. Okay, this may be remembered or not. This never asks, this equation never asks in your exam, since your semester exam also. So let us go into the last equation, today's last equation, the orthogonality of eigenfunction. So how can you say that orthogonality, two functions are orthogonal if what, if pm of x, pn of x into pm of x whole integration from minus 1 to plus 1, then this will be 0, then we can say these two functions are in orthogonal condition. Okay, this is the derivation of this thing, that is orthogonal. Again I say minus 1 to plus 1 pm of x into pn of x. Here pm and pn are two different functions having different type of m and n, that is constant, then this will be goes to 0. Then we said these two functions pn of x and pn of x are orthogonal. Okay, generally the two function, that is two different function, that is pm of x and pn of x, integration of these two function always 0. Okay, so you have to put in the problem these two different pn of x function is equal to 0, that is by the help of or the orthogonality property of the function, legendary function. Okay, thank you for watching. Bye bye.